students, welcome to Mathgotserved.com. In this clip, we're going to be going over problems 6 to 10 of the January 2017 Geometry Common Core New York Regents exam. Alright, let's take a look at question number 6. It reads, under which transformation would triangle A prime, B prime, C prime, the image of triangle ABC not be congruent to triangle ABC? So what does it mean for two figures not to be congruent? Let's go ahead and clarify what that is real quick. Something to note is that non-congruence, or two geometric figures being not congruent, non-congruence means that the size of the shape, the original shape, has been altered, okay? Has been altered by a transformation that is not an isometry, okay? That is not an isometry. Okay, so if you think about the word isometry, iso means the same, metry means measurement. So isometric transformations preserve the size, the measures of the sides and angles, okay? But any kind of transformation that's not an isometry alters the size of the figure, either the sides or the angles, and it results in situations where you do not have congruence, okay? Alright, so let's go ahead and take a look at isometric transformations, and then if we list all of them out, then it will be easy for you to see which options here results in an image that's not congruent to the original. Okay, so what you want to remember is that reflection, rotation, and translations are what types of transformation? And translations are isometries. These are isometric transformations in the sense that the size is the same. Okay? If you reflect the figure, rotate it or translate it, which basically means shifting, it doesn't change the size. Okay? But on the flip side, if you have a dilation, that makes it bigger or smaller. Dilation is not an isometry. Is not an isometry. Okay? Because in this case, the size is changed. If the size is changed, then the two figures are no longer congruent. Okay? So if you look at the options here, what do we have? Reflection is an isometry, so this one will result in congruency between the two figures. Rotation is also an isometry, which will result in congruency between the original and the image. Translation is also an isometry, which will result in congruence. But check this out. Option 4 is a dilation by a scale factor of 2. This is not going to be congruent because the image is going to be twice as big as the sides are going to be twice as long as that of the original. Okay? So what does that tell us? It tells us that dilating the original figure, triangle ABC, by a factor of 2 to yield the image, to yield a triangle A prime, B prime, C prime, results in a case where we have non-congruence. Okay, where triangle ABC is definitely not congruent to triangle A prime, B prime, C prime because of the dilation. Okay? So the answer for number 6 is option number 4. All right, let's take a look at number 7. It says the diagram below shows two similar triangles. If tan theta, of course referring to triangle, the first triangle, if tan theta is 3/7, what is the value of x on the second triangle? Okay, so let's label this triangle. Let's call this A, B, C. And then the triangle it's similar to is A prime, B prime, C prime. All right, so when you see the word similar, okay, similarity between triangles, what comes to mind? Well, we're looking at angles here. If two triangles are similar, corresponding sides are in proportion, and corresponding angles are congruent. Okay, so let's note that point down real quick. If two triangles are similar, then corresponding angles are what? Are congruent. Okay, and then corresponding sides are in proportion. So what does that tell us? It tells us that angle A is going to be congruent to angle A prime. Angle B, well, let's double mark this. Angle B will be congruent to angle B prime, and angle C, of course, these are both 90 degrees, which is obvious that they are congruent. Okay? All right, so based on this statement, we can easily tell that A is going to be angle A is going to be equal to angle A prime. Angle B is going to be equal to, let's do it this way. So angle A is congruent to angle A prime. Angle B is congruent to angle B prime. And angle C, of course, is congruent to angle C prime. We're told that tan of theta is equal to 3/7. Okay, basically tan A is telling us that tan A is equal to 3/7. Okay, since angle A and angle A prime are congruent, it follows that tan A prime is what? Exactly 3/7, because these two angles are corresponding, and since these triangles are similar, they're congruent. Okay, so A prime is also theta. So we have that taken care of. Now let's go ahead and look for x. So to find x, we're going to use a formula that relates the measure of two sides of a right triangle with a specified angle. Okay, so the formula we're going to use here is SOHCAHTOA. Okay, all right, so we have to pick the right ratio. Is it sine, cosine, or tangent? So based on what we have and what we need, we can easily determine the correct ratio to use. So based on the information that we're given, if you take a look at what we have here, we know that the tan function is tan A is 3/7, so that's a giveaway, okay, as to which one we're going to use. But let's assume that we don't know that, all right? Based on what we have here, we have this is the angle that we have some information about. So the side that's opposite this angle is opposite, okay? So this is the O in SOHCAHTOA. This is the side I know. The side I need is this side right here. This is the hypotenuse. The longest side, or the side opposite 90 degrees, and this other side is known as the adjacent. I don't know the hypotenuse, I don't need it, so I scrap it, okay? So I know opposite, I need adjacent. So which trig ratio has opposite and adjacent? It's tan. That's what TOA is for, okay? So we're going to use the variation of the SOHCAHTOA. The component we're going to use is tan theta equals opposite over hypotenuse, O over H, okay? All right, so let's go ahead and apply it here. So if we apply it, we have tan of A prime. I'm going to use, okay, so tan of A prime, that's the angle, equals opposite over adjacent. Okay, so we have tan of A prime is 3 over 7. The opposite is 2.4, and the adjacent is x. That's what I'm looking for, okay? So how do we solve this for x? Let's start by multiplying both sides by x. This is now algebra 1. Multiply both sides by x. Now, why did I multiply both sides by x? We're trying to get x isolated in the numerator position. X is in the denominator position, and that's a problem, okay? So when I multiply both sides of the equation by x, what results is that I have a situation where x becomes the numerator on the left side of the equation. So we have 3, 7x. Remember, the constant goes first, equals 2.4. Now to get x isolated, I need to get rid of this coefficient here. So I multiply by its reciprocal, so 7 over 3 on both sides. Multiply by 7 over 3, 7 over 3. And then we have x equals, now you input this into your calculators. I'm going to make sure my mode is in the correct format. Let me see here. It's in degrees. Alright. Alright, well, I don't even need that. So I have 2.4 multiplied by 7 over 3. And I get 5.6. Okay, so the answer for option number 7 is number 2. All right, let's take a look at question number 8. It reads, a farmer has 64 feet of fence to close a rectangular vegetable garden. Which dimensions would result in the biggest area for this garden? Okay, all right, so there are two formulas we are going to be using for this problem. We have area. We're going to be optimizing the area, and then we talk about enclosure. Okay, if you have a rectangular region and you have fencing to enclose a piece of land, what you're looking at is the distance around a region. Okay, and what is that called? That's the perimeter. Okay, so the two formulas we're going to be using for this problem, first of all, is the perimeter of a rectangle, which is 2 length plus 2 width. Okay, so this is the length and that's the width. And the area formula, which is length times width. Alright, so let's get started with the first piece of information. We have 64 feet of fencing that encloses the region, so that's the perimeter equation. So we have the perimeter is 2 length plus 2 width. The perimeter is 64, which is 2 lengths plus 2 widths. So I'm taking a look at different combinations of length and widths to generate the biggest area. So let's go ahead and get L and W by themselves. So to accomplish that, we'll simply divide the entire equation by 2. So we have 32 is equal to the length and the width. So if you add the length and the width, regardless of their combination, since it is a rectangle, you will always end up with 32. Okay, so we're going to be taking a look at different cuts for the length and the width and see which one generates the biggest area. Let's start with the first combination. The length is equal to the width. So if the length is equal to the width, what two identical numbers add up to give you 32? So let's make a chart on the side here, because we're going to be looking at different combinations of integers that yield a sum of 32. Okay, so let's put our width on the left and our length on the right. The goal is to get a sum of 32. If both of them are the same, just simply divide this by 2. 16 and 16 is what we're looking at. So for this scenario, option 1, the length is 16 and the width is 16. So what's the area going to be? Using the area formula, length times width, we have 16 times 16, which gives us an area of 256 square feet. Okay, option 2, it says the length is 2 more than the width. So what combination of two numbers add up to give you 32 where one is 2 more than the other? So if we start from 16 and 16, the base, if I take 1 out of 30 out of the width, which gives me 15, if I take 1 out of this, this is automatically 1 more. So if I take the 1 that I subtracted from this and add it onto that, it makes it 2 more. Okay, so this combination 15 and 17 has a sum of 32, which is the requirement, and it satisfies the requirement that the length 17 is 2 more than the width 15. So that works perfectly. In this case, length is 2 more than the width, so the width is 15 and the length is 17. Okay, so our area using length times width formula again is 15 times 17. 15 times 17 is 255 square feet. Oh, look at that. The area is shrinking. Okay, now let's take a look at the next combination. 3. The length is 4 more than the width. Okay, so how do we do that one? So it's 4 plus W. So now we're starting from 16, 16. If I take 2 out of 16, the width, I get 14. Taking 2 out of 16 generates a number that's automatically 2 less than 16. So if I add the 2 I took out of here and add it up to the 16, this becomes 4 more than 16. Than 14. Okay? So we have a situation where the sum is 32, requirements for the perimeter to be 32, and the length is 4 more than the width. Okay, so the width here is 14 and the length is 18. So the area is going to be the product of the length and the width, or the width and the length. It doesn't really matter. If you plug that into your calculator, you have 252 square feet. Foot square, and ooh, it's getting smaller. Let's take a look at option 4. The scenario here is that the length is 6 more than the width. Okay, so L is 6 plus W. Can you think about two numbers, two integers that add up to 32, but one is 6 more than the other? So all I'll do is, since I'm taking 6, I want this to be 6 more than the other. I'll take 3 out of 16, 16. That gives me 13. Taking out 3 from this number automatically makes this 3 bigger, since I took 3 out of here. If I add the 3 I took out of here to 16, that gives me 19. And this is going to be 6 times more than this, where the sum is equal to 32. Okay, so this combination works nicely. Bam, bam. And then our area is going to be the product of the length and the width, or the width and the length. Since multiplication commutes, the product here will be 247 foot square. Okay, so what's the answer? This option A is the biggest. This is the biggest. area. That's what we're looking for, biggest area. So answer to number 8 is option number 1. All right, let's take a look at question number 9. It reads, the diagram shows rectangle ABCD with diagonal BD. Question, what is the perimeter of rectangle ABCD to the nearest tenth? Okay, so if you take a look at this triangle, there are two ways you can do this. Well, first of all, we want to find the perimeter. So we are going to be using the formula like we used before. P is equal to 2 length plus 2 width. Okay, so we need to find the length and the width here. Okay, we need to find those two. Okay, so we can use SOHCAHTOA right triangle trick to figure this out, but there is a faster way to solve this problem because we have a scenario where we have 30, 90, and this has to be 60 degrees. Do you recall what this is called? This is one of the two special triangles. Okay, so we're going to use one of the special triangles, the 30, 60, 90 special triangle. Let's take a look at what that looks like. So let's say we have the following scenario: a special triangle where the angles are 30, 60, and 90. Okay. All right. So what do we have here? This is 30, 60, 90. It's not drawn to scale. Okay. There's a special relationship between all special triangles because they're all similar. Okay. The shortest side is x. The longest side is twice that, and the other side is x rad 3. So using this setup, we can easily determine what the width and the lengths are using the fact that they're similar and setting up similarity ratios. So using corresponding sides, we can automatically see that this side right here, the hypotenuse corresponds to 12. So 2x is equal to 12. Dividing that by 2, let's change colors here. So 2x is equal to 12. Divide that by 2. And you have x equals 6. Okay? Alright, so we know what the width is. The width is going to be 6 units long. We also need the length. So the length is x root 3. So if x is equal to 6, that means that x root 3 is going to be 6 root 3. And that will be our length. Okay, so this would be 6 root 3. Now we are in business. We know the length and we know the width. So these are the two pieces of information we need to compute the perimeter, which is 2 length plus 2 width. So we have 2 length, 2 times 6 rad 3, plus 2 width, which is 2 times 6. I will simplify that. We have 12 root 3 plus 12. This is the exact answer, but we need the answer in approximate form, rounded to the nearest tenth. So let's go ahead and input our answer in the calculator for the approximate value. Okay, so 12 root 3 plus 12 yields 37.78. To the nearest tenth, we have 32.8. That's the perimeter of the of the rectangle to the nearest tenth. Okay, so the answer is option number 2. Okay, so let's take a look at question number 10. It says, identify which sequence of transformations could map pentagon ABCDE onto pentagon A double prime, B double prime, C double prime, D double prime, E double prime as shown below. Okay, so we have 4 options here, a combination of 2 transformations. and let's see which one is the correct one. So let's start with option 1. Option 1 talks about a dilation followed by a rotation. So if you have a dilation followed by a rotation, this dilation means that the size will be altered, okay? But does it look like the size of the image is different from the original? The answer is no, they look identical, right? So since they have identical sizes, that means there are no dilations, all right? So we have same size, which implies we have no dilations happening here. So option 1 is automatically eliminated. Okay. 2, 3, 4. Which is the correct one? So what we're going to do is take a look at each case, okay? So I have 3 diagrams here that I will be using to illustrate the transformation so you can clearly see what's happening. Let's start with option 2. We have a translation to take you to the prime, and then a rotation. Does this work? Alright, so let's try it out and see if it works. You don't have to draw the entire shape for the transformation. You can just focus on one point. Okay. So if I focus on just point E, focusing on point E, if I do a translation, because my goal is I want to get it here. Okay. If I do a translation and in such a way that it lines up perfectly with this point right here, this point right here will be E prime. Okay. And then if I follow it with a rotation, it's going to take it to this point right here. This point will be E double prime. Does that work? The answer is no, because E prime, E double prime is not equal to A double prime. We need to have a perfect match. Okay, so when you translate and rotate, E prime ends up right here, but this requires E prime to be on the right. So option 2 is a fail. Now let's take a look at option 3. We have a line reflection followed by a translation. Will that work? So when we have a line reflection, so let's write out what we're doing here. Reflection followed by a translation. So if you reflect, let's just focus on E. What's going to happen? It's going to flip downwards right here. E is going to end up there. That will be E prime. Followed by translation, if I shift it to the right, E prime is going to end up right here, E double prime. This is perfect. Okay? And at this point, A goes here, and then when you shift it, A double prime. So it works out perfectly in this case. So the answer is option number 3. Okay? So let's just do 4 just to help you see that that's the correct answer, and also just sharpen your skills in composite transformations too. Okay, so for 4 we have a reflection, a line reflection, followed by another line reflection. So if we carry out 2 reflections, will we end up with a shape with this configuration right here? Well, let's see. If we do a line reflection, it could be to the right or to the left, and then it could be to the right or downwards, and then do another one to the right or downwards. Okay, so let's reflect downwards first for our line reflection. If we reflect downwards, E prime will be right here. So this is the starting point E. When you reflect downwards, E prime is going to be right up there. Let me move it up a little bit. So if you reflect down, you're going to have E prime right here. Now, if you reflect again to the right, what's going to happen? E prime is going to end up right here. This would be E double prime. So what you have is a situation where E double prime and A double prime are on top of each other. Are they the same? The answer is no. E double prime is not equal to A double prime. So this sequence of transformations does not work also. So we can clearly see that the answer is option number 3. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents exam, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments, just place it in the comment section below and we'll be more than glad to support you. Do not forget to subscribe to our channel for updates to other cool tutorials such as this. More clips can be found on Mathgotserved.com, including formulas, tips, and tricks to help you do well on the exam. Thanks again for watching and have a wonderful day. Goodbye.